Hello guys, my name is Arun and welcome to my channel. This series is actually a series of tutorials on Fortran Hacks wherein I'll be explaining you guys some interesting concepts which were not dealt in my other two programming series, namely Fortran Programming and Advanced Fortran Programming. Okay, um, this video is actually a sequel to the video which I've included previously. Okay, in this video I'll be talking to you guys about preprocessor directives. Now, what's a preprocessor directive? It's simple. The preprocessor directive is actually kind of how do I put it? This is actually a C kind of a C program construct, which kind of it got which became very famous and popular in Fortran after the concept was introduced in C. Now, what it does is as follows. Now imagine you define some certain global variables, uh, which tells the compiler as to how certain compilation and execution should behave. Okay. Now all your commands and statements tell your compiler to do this job and that job and everything. Just tell the compiler to, okay, I want to do this, I want to do that. Okay, but none of these commands give instructions to the compiler to do his job. They just say that, okay, I want to do this job, help me. I want to do this job, do with that, like that. That's it. But there are commands which tell the compiler to behave in a certain manner. Okay, it's like actually your boss. It's like compiler is your boss, and all the commands are its employees, and the employees will say that, okay, I want to work this, help me with this, and your boss will help like that. But there are commands which actually tells your compiler to behave in a certain manner, and those are preprocessor directives. Imagine somebody who tells your boss to behave in certain manner. That's like that. Preprocessors are like that, and what they do is that they kind of help you to make the same program run in different methods and different operation in different patterns, which kind of becomes kind of becomes messy. For instance, let's take the simple example of running Fortran in different operating systems. I'm using Linux, I'm using Ubuntu, and I'm using a 64-bit system, and I'm using G Fortran to run for my all my Fortran programs. Now, if you guys are running an Intel, let's say, uh, Intel Fortran and in Windows and 32-bit Windows, let's say, then definitely the array sizes or the integer sizes might change. Now the problem is if I were to define all the if I were to fix the sizes of arrays and everything based on Linux, let's say, then they may not fit the array dimensions and specifications of Intel. Intel in the Windows 32-bit system. Yes. Now now the thing is, for that you have to remake all the arrays and do all the arithmetic kind of make corrections to everywhere, isn't it? But that's difficult. Okay, because there's a compiler, because they change with respect to the compilers, and sometimes in certain compilers certain optimization flags or certain optimizations will be possible. For instance, when compared to G Fortran, maybe there might be some extra features available in Intel which can make the program run faster. And if you want to access those and everything, and if you want to see whether there are some certain variables outside, and you have to, it's kind of necessary. It's kind of necessary to know how whether they are available or something, so that you can make your program run faster. And sometimes what happens is that if you just open your shell command or command terminal and everything, there will be some, you might like to pass certain global variables through them. Okay, certain global variables through them into your Fortran program, thereby making the program run in a different manner. And if you want to do these kind of really fancy stuff, these are actually really fancy stuff. Okay, if you want to do those kind of stuff, your pre-processor directives help you in tremendously. Okay, so in this program what I'm going to do is that I'm just defining is that it's very simple and straightforward. It might be a little messy, but I'm just going to help you guys explain what's going on. I just written this. It's exactly the same program which I've written for my previous Fortran Hacks video of saving, writing and saving data to binary files. Okay, except that I define preprocessors over here. Now, what I've done is this follows. I define two preprocessors. Okay, and in Fortran, and just like in C programming, the preprocessor is defined with a hashtag, and you define to create a preprocessor variable. Just like how we include a global preprocessor variable in C, you write hash and then write define. That's a keyword, and then after that you set you write the value of you write your preprocessor directive, okay, variable. And then if this variable has some kind of value, you can write next to it. Simple as that. Okay, and this way you can define multiple preprocessor directives. And then if you want to remove it, if you want to make any preprocessor directive inactive but don't want to delete it from the program, just comment it out. That's simple enough. If you comment it out, what happens is that that command will be there, but you will avoid its usability. You'll just ignore it, and you can if you want to make corrections to it, you can just directly do it like that. So I'm defining two preprocessor directives, seq and dir. And if you guys watched my previous tutorial carefully, you might understand that seq stands for sequential mode. Okay, in my previous tutorial I'll be writing the file. I would have written the data into the files using sequential mode and then in direct access mode. So instead of commenting out those lines manually, I just have to make one correction over here, a little bit of pain over here, little bit of adjustments over here, kind of painful adjustments to start with, especially in the typing part, but it saved a lot of pain afterwards, and saved a lot of commenting and uncommenting stuff afterwards. Okay, what I've done here is this. I defined two preprocessors like this, and I've written several lines between preprocessors. Okay, now I'll explain what's going on in here. I'm just saying that if I were to run this program, and if this preprocessor seq is defined, okay, and this command if def means if defined. Okay, so it says that if this preprocessor seq is defined, then do this operation and end this if definition, and that's what it says. Okay, and then this command says exactly the same thing. If dir preprocessor is defined, okay, then do this operation and end this operation. This is what it behaves. Now here's the thing. Now if this preprocessor is available, if this defined, and this will do this operation will do. If not, this command will be ignored. Okay, and similarly, if this preprocessor is active, if this preprocessor is active, this command will be executed. Okay, and similarly, this you might find that okay, I can use a simple if to define all this, right? And here comes the interesting part. You see this part over here? This is where the magic comes in. This is where the real magic of preprocessor comes in. Now I just said that I've just written the entire open command in multiple single different lines, separate using preprocessor directives. I just written like if define dir, meaning direct access. Okay, if dir stands for direct access over here, which I define on the top. Okay, if I define this variable preprocessor directive dir, then let the file have parameters access to be direct, and let it have a record length given by m times n times o times p times 8. Okay, and end it. Okay, now if this directive is not present, then these two lines will be ignored. Okay, and now if this directive seq is present, then this line will be included along with this line. So what happens is that these two lines will be there and this line will be there if seq is defined. Otherwise, if dir is defined, this line will be there and these two lines will be there and this line will not be there, because I'm not going to activate both of them. Similarly, the same way, okay, if direct access is defined, then this line is going to be printed and this will not be there, and like that I'm just using this if def for dir seq all the time. Everywhere. Similarly, just like how we did on the top, I'm repeating the same process over here, and exactly the same thing. Now the only thing is, if I want this file to be running in a sequential mode, I have to uncomment this line and comment this line. This way I'm running the file in sequential mode. So to make it possible, and you know and let me reduce the size of these arrays so that it's kind of easy to follow. It kind of quick, it runs out perfectly. So what I have to do is I just have to compile, build and execute this manually, or I can use the terminal directly. But anyway, let me type compile this manually, gfortran -c and binary underscore check.f95, compile it. There you go, and I have the object file ready over here, and then I have to type gfortran star.o and then -o flag, and then type binary.exe, press enter, and then I have the executable ready. So if I type binary.exe, let me raise this up, press enter, and there you go. See, you have to keep in mind. Now let's see. It says that the file access is in sequential mode, and the data has been written into A, B, and C, and the data has been read from A, B, D, read to D, E, F, and the values are being printed. Fair enough. Now let's do the same thing this time with direct access. Let's see how that goes. Now what I have to do is that to make this file run in direct access, I just have to uncomment this line and comment this uncomment this line and uncomment this line. Now what will happen is that all the statements where your sequential stuff will be, or where your all the lines where your sequential mode was active, they'll not be working, whereas all the lines where the direct access preprocessor is present, those lines will be working. Okay, so let me clear the screen, clear this terminal, and push it a little bit, and then clear this up again. Alright, we compile this, build this, and then I execute it. Now watch. It says file access is in direct mode, and then everything else is exactly the same procedure. Now that's interesting, right? Now the thing is, just by now, if you guys notice, instead of me commenting throughout the program, throughout commenting and uncommenting lines throughout the program, okay, to make the same program run in different methods, I just commented one single line, and that's it. It makes sense. On the other hand, what I can do is that I just show you the other file. Okay, I'll just open this in Genie as well. See, on the other hand, this is exactly the same program which I've written over here, okay, which does the same thing. But thing is, here, if I want the file to be direct, I have to if I want this file to be sequential, I just have to uncomment this and comment these two lines for it to work. Okay, and then I have to comment this, uncomment this, uncomment this line, comment, alternate the comments positions, and then I have to do the same procedure over here. Same procedure over here. You see, this is actually painful. Like it might be a little bit of it might look like a bit of a small job in the beginning, but it's kind of like really painful, because you have to make the corrections everywhere, and that's kind of annoying, really annoying. On the other hand, what I have to do, I just have to take some pain and write these preprocessor directives in the file directly, and that's about it. And that's about it. All I have to do is that I just have to change the preprocessor definition on the top and then compile it, and the Fortran program takes care of it directly. So that's about this part. So let me just make it proper again. um, yeah, let me make this proper again, and that's and direct access, right? And there you go. And I guess that's, yeah, okay, that's about it. Okay, that's about it. Now this way, by changing the preprocessor data on the top, I can make the same function, same program do multiple options. Now here's the thing, I just define only two preprocessor on the beginning, so I can make a lot of options, and everything, make it done only two options here. Here's the thing, I can define like multiple preprocessors on the top and activate or deactivate any one of them as per my choice, and based on that I can make a single program do multiple different stuff in a simple way, in one shot. For instance, if I want to run a program, if you want to run a program and I want to run the program in a debugger mode, I can have a preprocessor active to enable debug. And then if I want the program to test it, I can have a test it preprocessor to test it, and if I activate that, the testing mode will begin. If I start the preprocessor directive mode with if I start the preprocessor directive mode with debugging, it will debug. If I comment it out, it won't debug, it will just work the way. And then based on this I can make multiple options to work it out. And then just to give you guys a complete closure about this, I'll just go to the preprocessor directives and I'll show you something interesting. So if I were to type let me clear this terminal. If I type G Fortran minus E with a capital, and then type binary F95 and press enter. Check it out. If I do that, what happens is as follows. I'm getting all these commands over here, and guess what? I've made a sequence. I made direct to be. I just defined direct over here. So if I define direct over here in this preprocessor, so wherever sequential comes, the command corresponds to preprocessor data sequence is not there, so those commands are taken out, whereas those commands that corresponds to dir which are present, they're actually maintained as it is. Okay, and you can see in those places where if this preprocessor is defined, they become empty lines. Okay, and similarly everywhere in the program, wherever dir is defined, that part is removed, whereas the functions, whereas the command lines are maintained. But those places where the sequence is present and their commands are present, they're taken away. So you get a file like this. On the other hand, what I can do is that if I were to write the same command and put an arrow and type this to binary dir dot f95, let's say, and check this out. This one. This will say that binary. It says you have a new file called as binary underscore dir dot f95. I'll open this and gedit. Okay, and at the same time I will open this binary file which I've written over here, and let's compare these two files. If you look at these two files and compare it, they'll be exactly the same, just like in direct access mode. They'll be exactly the same. Now that's what it happens. Okay, and also you'll have a few extra comments on the top, like they'll be like preprocessor directive stuff, just to indicate from where these preprocessors are being built, and that's about it. Other than that, it's okay. Okay, other than that, this is not a big deal. Okay, you can even remove those. So this is what happens under the hood if you were to use preprocessor directives. This becomes a really handy tool when it comes to parallel programming and stuff. For instance, if you were to use OpenMP or MPI, and if you want to write both parallel programming architectures in the same program, let's say, okay, and if you want to switch between OpenMP and MPI, instead of writing and uncommenting several hundreds of lines that you might have to come across, just define some compiler flags, define OpenMP, define MPI, and then if you want to switch it back, just uncomment or comment the lines and compile them with the compiler flags and everything, and that's about it. And simple as that. Your life will be much simpler, and you don't have to switch between them very rapidly. Okay, that's one of the advantages. And these are not the only preprocessor directives available, preprocessor commands available. There are like several preprocessor commands that are available. You can have a look at that. This is just a simple explanation. I mean, this is like an elaborate explanation for a very simple preprocessor directive, and to give you guys an introduction. And if you guys understand how this preprocessor directive works, you guys will, and if you guys are already good in programming, which I assume that because you're watching these series, you guys will understand the remaining concepts quite nicely and very easily with respect to preprocessor directives. Okay, and that's all I have for you guys in this tutorial, and thank you guys for watching, and I'll see you guys in another tutorial with some other interesting concept, and take care, and then take care.